You can probably guess what's next. We just did multiplication with fractions, but none of them had variables, did they? So now we're going to integrate some variables within the fractions. The thing is, nothing changes. I want you to start making connections with all this stuff. Fractions and their operations work the same whether you're dealing with numerical fractions or algebraic fractions. If they're just numbers or if they have variables in them. Variables are numbers. They're just numbers that we don't know what they are at that moment. So the first question is, what is 2/3 of 6x? And I started with this one because it was what we ended with last time. When we want to find a fraction or a percent or decimal of something, we multiply to find that. And in the last video, we examined a visual, why it works like that. So what we're going to do is take 2/3 and multiply it by 6x. So one of the things we learned is that you can take a whole number, whether it has a variable or not, and put it over 1. We can always put a whole number over 1. They mean the same thing. We're just changing the way it looks. And a lot of the times we do that in algebra simply to make sure we get things lined up right, make sure we are doing the operations with the correct parts of the fractions in this case. And if you recall from the last video, we have a couple ways we can do that. You can multiply straight across and then take that answer and simplify it. Or, and this is going to be the way I'm going to approach it, we take everything and factor it immediately. So we've got 2/3, can't factor it. 2/3 is 2/3. They're both prime numbers. However, 6x can be factored to be 2 times 3 times x. It's the same thing. We're just showing the ingredients, right? We're showing the the building blocks of the number, and then 1 goes on the bottom. And now we cancel. So we factor and then cancel. Well, what can we cancel? If I recall, canceling is removing common factors between the numerator and the denominator. I see 3's, and that's it. Don't try to cancel the 2's. They're both in the numerator. So what do we have left? We've got, sometimes it's nice to even highlight what you have left. We've got a 2, and an x on top, and a 1 on the bottom. So 2 times 2 times x is 4x over 1. Simplify that. Kind of like the opposite of what we did here. You're going to take the 1 away. Down here, you're going to divide by 1, which gives you what you had on top, 4x. Okay, let's look at some more. So we're multiplying and simplifying. How about this? X over 3 times y over 5. Pause the video, think about it, try it. Stare at it, do something. So here we have a fraction, some number over 3, some number of thirds times some number of fifths. Well, even sort of ignoring just the rules that you're supposed to follow, you know that you multiply the numerators together, you multiply the denominators together, and x times y is just, again, some number times some other number, and we can't do anything extra with that because they're different variables, so we just write it as xy. And 3 times 5 is 15. I couldn't factor anything, I couldn't simplify anything. That's all we can do. Merge them into one fraction. Let's have some fun now. 8x over 15 times 10y over 14x. Pause the video, try it. And try the prime factorization way. Try multiple methods, right? Try different ways. So I'm going to factor each thing. So I'm going to go, fraction by fraction, part by part. 8x. So that is 2 times 2 times 2 times x. Do your factor tree and you'll come up with that for the number 8. Over 15. 3 times 5. Come up with some sort of method that works for you. Times. Draw my next fraction bar. Let's try 10 times y. 10 is 2 times 5, so 2 times 5 times y. 2 times 5 times y. And then 14x on the bottom. Imagine the factor tree just for the numerical part would be 2 times 7, and the variable you can separate pretty easily. There, hey, we're done. We've done the hard part. That's the hardest part of this whole problem. Now when you start to have a lot of factors here, I always suggest working across the top, left to right, and seeing what can cancel. This 2 can cancel with this 2. These 2's have to stay. Actually, I'm going to highlight them as we go, right? Because this has to stay, and this has to stay. This x can cancel with this x. This 2 has to stay. This 5 can cancel with that 5. And this y has to stay. And if I've done everything properly across the top, then I shouldn't have anything left over on the bottom that can cancel. But I'm going to just check. I'm going to double check. There are no 3's on top, and there are no 7's on top. And I'm also double checking to make sure that they were prime numbers and that they didn't have any factors that I missed. Looks like I got them all. So now we put everything back together. Make sure you just keep the stuff on top that belongs on top. 2 times 2 times 2 times y, remember just the highlighted stuff, would be 8y. And on the bottom we have 3 times 7, which is 21. 8y over 21. There we go. So let's try one more. And this time I'm going to mix it up a little bit with some negatives. Negative 4xy over negative 9x, or I'm sorry, negative 9y times negative 12 over 6xy. Now we haven't done any with negatives yet. We haven't tried any, but I want you to try it and see if you can figure out what to do. So give it a shot on your own. Pause the video, try it, and come back here. So I'm going to do the same thing. I'm going to go through each thing and factor it, okay? So we have negative 4xy. Now, you can do this a couple different ways. I'm going to ignore the negative for just a second and write it as, I'm going to write it below this time, just for the sake of space. 2 times 2 times x times y, right? 4xy. So what do I do with the negative? I could put it right out there. Just put it out front. And then cancel the negatives. But the problem is you might get confused thinking, can I cancel a negative 2 on top with a regular 2 on the bottom? The answer is yes. The negative just stays. But a lot of people end up with that question and they're not sure. So my recommendation is that when you have a negative and you're doing factorizations, you factor the negative out as a negative 1. And then they'll all just sort of take care of themselves. Let's look at what happens on the bottom. Negative 9y. I take the negative out as a negative 1. It's like negative 1 times 9. And then 9 is 3 times 3. And so I don't have to worry now about, does this cancel with this? I know that there's a negative 1 and a negative 1 that will eventually cancel. Let's keep going. Let's get that y down. And now we go to the next fraction. Times. Negative 12. Negative 1 times, then 12 would be, you do a factor tree, 2 times 2 times 3, over 6xy. 6 is 2 times 3, and then x is a number, so times x, and y is a different number, times y. Lots of 2's, lots of 3's. We want to make sure we get them all. So, left to right across the top. Negative 1 cancels with negative 1. 2 can cancel with this 2. This 2 can't cancel with anything, so it's going to stay. X cancels with x. Y can cancel with, it doesn't matter, I'll pick this one, y. The negative 1 is going to stay. The 2 is going to stay. This 2 is going to stay. And then the 3 will cancel with a 3. And then I'm going to double check across the bottom. This 3 can't cancel with anything. This 3 can't cancel with anything. And that y can't cancel with anything. They're all prime numbers. So I did all my factoring and canceling properly. Now we just have to make sure that we put it all back together the right way. So we have 2 times negative 1 times 2 times 2, that is negative 8. And on the bottom, 3 times 3 times y is 9y. And that is multiplication with fractions when you have variables.